The fire started below deck, a spark, a flash, then smoke rising like a warning no one wanted to believe. By the time the alarm sounded, flames were already crawling through passageways, feeding on oil, paint, and oxygen. Men ran toward the heat, not away from it. They carried wrenches, not weapons. They turned wheels, sealed hatches, and closed small metal doors, hundreds of them, while the ship groaned beneath their feet, and the ocean waited just beyond the hull. This is not a story of cannons or torpedoes. It is a story of compartments, valves, and the silent architecture of survival. During World War II, damage control became the difference between a ship that sank and a ship that limped home. Engineers, sailors, and damage control teams learned that victory at sea was not always won with firepower. Sometimes it was won by closing 200 little doors before the flames could spread. It was a war fought in narrow corridors, flooded compartments, and engine rooms filled with smoke. It was a war where every hatch mattered, every sealed door bought time, and every man who stayed behind to turn a valve became part of a system designed not for glory but for endurance. The ocean does not forgive mistakes. Fire does not wait. And in those moments, survival depended on discipline, design, and the willingness to trust that small actions could save everything. Before we continue, subscribe and turn on the bell. Here we tell real, untold stories of World War II, stories of engineering, sacrifice, and the fragile systems that kept men alive when everything else was burning. The lesson came early in the war, and it came in fire. A destroyer took a hit amidships, not from a torpedo, but from a shell that punched through plating and ignited fuel stores below deck. The explosion was small. The fire was not. Within minutes, flames spread through passageways, feeding on paint, wiring, and anything that could burn. Men scrambled to fight it, dragging hoses through smoke so thick they could not see their own hands. But the fire moved faster than they did, jumping from compartment to compartment, climbing through open hatches, racing toward the magazines where ammunition waited in silent rows. The ship did not sink from the hit. It sank because the fire could not be stopped. By the time the captain gave the order to abandon ship, the flames had consumed half the vessel. Men jumped into the ocean and watched their ship burn down to the waterline before slipping beneath the surface. The survivors floated in silence, rescued hours later by ships that passed through a slick of oil and ash. Back on shore, engineers gathered in windowless rooms and studied the reports. They read witness accounts, examined blueprints, and traced the path the fire had taken through the ship. What they found was not a failure of courage. The crew had fought until the last moment. What they found was a failure of design. The ship had been built for battle, but not for survival. Hatches had been left open for ventilation. Watertight doors had been propped back for ease of movement. Compartments were connected by passageways that allowed air and fire to flow freely from bow to stern. The conclusion was simple and unforgiving. A ship was only as strong as its ability to contain damage. If fire or water could travel unchecked, no amount of armor or firepower mattered. The ship would die from within. Damage control became doctrine. Naval architects redesigned compartments, adding bulkheads, reinforcing hatches, and dividing ships into isolated sections that could be sealed off in seconds. Engineers calculated how much flooding a ship could survive, how many compartments could be lost before the vessel capsized. They mapped out fire zones, ventilation pathways, and emergency routes. They built ships not just to fight, but to endure. Sailors were retrained. Damage control parties were formed. Teams of men assigned to specific sections of the ship, responsible for sealing hatches, fighting fires, and managing floods. They drilled endlessly, practicing in darkness, in smoke, in simulated chaos. They learned the location of every valve, every hatch, every fire extinguisher. They learned to move by touch when visibility dropped to zero. They learned that survival was a system, not a miracle. The new rule was absolute. When the alarm sounded, every hatch had to be closed. Every watertight door had to be sealed. Compartments had to be isolated before the fire or flood could spread. It sounded simple. It was not. Closing a hatch meant trapping men on the other side. Sealing a compartment meant accepting that whoever was inside might not get out. It required trust in a system that valued the ship over the individual, survival over sentiment. The first time a crew executed the new procedures under fire, the fear was palpable. A cruiser took a torpedo hit below the waterline, flooding 2 compartments instantly. The damage control officer gave the order, "Seal the hatches." Men ran through passageways, turning wheels, dogging down latches, checking seals. Within 90 seconds, the flooded compartments were isolated. Water stopped spreading. The ship listed but did not capsize. Pumps were activated. The remaining crew shifted weight to balance the vessel. The cruiser limped back to port under its own power. Word spread quickly through the fleet. Ships that followed damage control doctrine survived hits that would have sunk them a year earlier. Crews that sealed compartments fast enough bought time to fight fires, control floods, and keep engines running. The small metal doors, hatches, valves, bulkheads became the unseen armor that mattered more than steel plating. But the system demanded everything. Damage control teams worked in conditions that defied description. Flooded compartments where water rose to their chests, engine rooms filled with steam hot enough to blister skin, passageways choked with smoke so thick that breathing felt like drowning. They worked by feel, by memory, by trust in training. They turned valves they could not see, sealed hatches they could barely reach, and stayed behind when evacuation orders were given because someone had to ensure the doors were closed. The fire did not care about bravery. The ocean did not reward heroism, but the system worked. Ships that should have sunk stayed afloat. Crews that should have died made it home. And in the archives, tucked among casualty reports and battle summaries, were quiet notes about men who never left certain compartments, men who closed the last hatch from the inside, ensuring the fire would not spread, knowing they would not get out. A warship was not one vessel. It was dozens of smaller vessels stacked and sealed within a single hull. Each compartment was designed to function independently, separated by watertight bulkheads and steel doors that could transform a single ship into a honeycomb of isolated chambers. When damage struck, survival depended on how quickly those chambers could be sealed, how effectively the crew could contain the breach, and how well the ship's architecture could absorb punishment without collapsing entirely. Engineers studied every detail. They calculated the volume of water each compartment could hold, the weight distribution if flooding occurred, and the maximum list angle before capsizing became inevitable. They designed pumps that could move thousands of gallons per minute, ventilation systems that could clear smoke in minutes, and drainage routes that channeled water away from critical areas. They built redundancy into every system: backup pumps, alternate power sources, emergency steering controls. If one system failed, another had to take over instantly. The challenge was not just structural, it was human. A ship's crew had to understand the vessel as intimately as the engineers who designed it. Damage control teams memorized deck plans, learning the location of every hatch, valve, and bulkhead. They practiced in darkness, navigating by touch through passageways they could not see. They trained with smoke machines, learning to breathe through cloth masks while dragging hoses and operating valves. They rehearsed flooding drills, wading through waist-deep water while sealing hatches and activating pumps. The drills were relentless. Officers timed every movement, measuring how long it took to seal a compartment, how quickly pumps could be activated, how efficiently crews could reroute systems when primary controls were destroyed. Mistakes were corrected immediately. Slowness was unacceptable. The standard was absolute. When battle damage occurred, the crew had to respond faster than the fire could spread, faster than the water could flood, faster than chaos could overwhelm discipline. The doctrine was simple: isolate, contain, control. When a hit occurred, the damage section had to be isolated immediately. Hatches sealed, ventilation closed, power cut if necessary. Once isolated, the damage had to be contained. Fires fought with extinguishers and hoses. Floods managed with pumps and patches. Only after containment could control be re-established, assessing structural integrity, restoring power, compensating for weight shifts, and determining whether the ship could continue fighting or needed to withdraw. But the doctrine required sacrifice. Sealing a compartment meant abandoning anyone still inside. Cutting power to a damaged section meant leaving men in darkness. Flooding a magazine to prevent an explosion meant accepting the loss of ammunition and anyone nearby. The decisions had to be made in seconds, without hesitation, without sentiment. The ship's survival outweighed individual lives. It was a calculus that no one spoke about openly, but everyone understood. The first test of the new systems came during a night engagement. A battleship took 3 shell hits in rapid succession. One penetrated the hull below the waterline, another struck an ammunition handling room, and a third ignited fuel stores near the engine room. Alarms screamed through every deck. Damage control teams scrambled into action. In the flooded compartment, sailors worked in chest-deep water, feeling for valves in complete darkness. They sealed the bulkhead doors, isolating the breach. Pumps roared to life, pulling water out faster than it could enter. In the ammunition room, a fire blazed through racks of shells. The team doused it with foam and water, knowing that if the flames reached the magazine, the entire ship would be lost. In the engine room, smoke filled every corner. Engineers crawled along the deck, shutting down fuel lines, rerouting ventilation, and keeping the turbines running despite the heat and the choking air. 30 minutes after the first hit, the ship was still afloat. The flooded compartment was sealed and stabilized. The fire was extinguished. The engines were running at reduced power but functional. The battleship withdrew from the engagement, limping toward port with a 15-degree list and half its crew working pumps around the clock. It should have sunk. Instead, it survived, not because of armor, not because of firepower, but because 200 little doors had been closed in time. Now tell us in the comments where you're watching from, and how far these forgotten wartime stories have reached. Your voice helps keep memory alive. The lessons spread through the fleet. Damage control became as important as gunnery. Crews drilled constantly, refining procedures, improving response times, learning from every engagement. Engineers analyzed every battle, identifying weaknesses, recommending modifications, updating protocols. Ships returned from combat with damage reports that included not just what hit them, but how the crew responded, what worked, what failed, and what needed to change. The architecture of survival was never perfect. Ships still sank, fires still raged out of control. Men still died in flooded compartments trapped by sealed hatches they could not reopen. But the doctrine worked more often than it failed. Ships that followed the procedures survived hits that would have sunk vessels a year earlier. Crews that trained relentlessly saved ships that should have been lost. And in the silent spaces between battles, in the machine shops and drafting rooms where engineers studied blueprints and casualty reports, the system was refined again and again, always searching for the balance between strength and flexibility, between armor and survival. When the torpedo struck, it did so without warning. A sudden concussion that lifted the deck and threw men against bulkheads. The explosion tore through the hull below the waterline, opening a gash 12 feet wide. Water poured in with the force of a collapsing dam, flooding the compartment in seconds. The lights went out. Emergency lanterns flickered on, casting weak yellow circles in the darkness. Somewhere in the chaos, the damage control alarm began to wail. The men assigned to that section knew immediately what had to be done. They did not panic. They did not freeze. They moved with the mechanical precision of training, grabbing tools, checking seals, and moving toward the breach even as water rose around their legs. Their job was not to escape. It was to contain, to seal the hatches, to isolate the damage before it could spread, to buy time for the ship and everyone aboard. One man reached the primary hatch and began turning the wheel, dogging it down with methodical force. Water was already knee-deep, rising fast. Another man waded to the secondary bulkhead, checking the seal, ensuring no water was leaking through. A third man worked the valve that would shut off fuel lines running through the compartment, preventing fire from joining the flood. They communicated in short, clipped phrases. Status reports, confirmations, adjustments. There was no time for anything else. Outside the compartment, officers monitored the situation from Damage Control Central, a small room filled with diagrams, status boards, and communication lines to every section of the ship. They could see which compartments were flooded, which hatches were sealed, which pumps were running. They could calculate how much weight the ship could carry before capsizing, how long the pumps would take to stabilize the flooding, whether the vessel could remain combat effective or needed to withdraw. The decision came quickly. Seal the compartment. The flooding was too severe, the breach too large. If water continued spreading, it would reach the engine room and the ship would lose power. If it reached the magazines, the risk of secondary explosions would increase. The only option was to isolate the damage completely, trapping the flood in a single sealed chamber. The order was transmitted over the intercom, calm and clear. Seal compartment 7. All personnel evacuate immediately. The men inside heard it. They knew what it meant. They had 30 seconds, maybe less, to finish securing the valves, to ensure the hatches were properly dogged, to make certain the compartment was truly isolated. Water was waist-deep now, cold and black, filled with debris and oil. The emergency lanterns cast long shadows on the rising surface. One man made it to the exit hatch. He pulled himself up the ladder, water streaming from his uniform, and climbed into the passageway above. Another followed, coughing, gasping, moving as fast as exhaustion allowed. But the third man, the one at the fuel valve, was still below, still working in chest-deep water, still turning the wheel to ensure the line was fully closed. The officer in Damage Control Central watched the clock. 15 seconds, 10. The compartment had to be sealed. The ship's survival depended on it. The man at the valve finished his work. He turned toward the ladder, wading through water that now reached his shoulders. The current was strong, pulling him off balance. He grabbed a pipe, steadied himself, and pushed forward. 5 meters to the ladder, then 3. The hatch above began to close. The man still outside reached for it, hesitated, looked down into the compartment. He could see his crewmate struggling through the water, fighting to reach the ladder. He held the hatch open, shouting encouragement, willing the man to move faster. But the water was rising too quickly. The compartment was nearly full. If the hatch stayed open, the flood would spread into the passageway, into adjacent compartments, into the rest of the ship. The officer's voice came over the intercom again, sharper now. "Seal the hatch. Now." The man at the hatch looked down one last time. His crewmate was still 3 meters away, chest deep in water, reaching for the ladder. Their eyes met. No words were exchanged. There was nothing to say. The man above began turning the wheel, dogging the hatch shut. It closed with a heavy metallic clang, the seal locking into place. Inside the compartment, the water continued to rise. The man trapped below stopped moving toward the ladder. There was no point. He turned instead toward the emergency air pocket near the overhead, where a small space remained above the waterline. He pulled himself up, braced against the pipes, and waited. The water climbed higher. The lantern went out. Darkness settled over everything. Above, in the passageway, the man who had closed the hatch stood motionless, one hand still on the wheel. He did not move. He did not speak. Other crew members passed him, rushing to their stations, carrying equipment, shouting orders. He remained there, staring at the sealed hatch, until an officer pulled him away and sent him to another section where hands were needed. The ship stabilized. The flooding was contained. Pumps worked through the night, draining water from adjacent compartments, restoring balance. The vessel remained afloat, combat-capable, able to continue its mission. In Damage Control Central, the officer marked the flooded compartment on the status board with a red X. The notation was brief. Compartment 7 sealed, 1 casualty, flooding contained. The war continued. The ship continued. But in the sealed compartment below, water lapped quietly against steel walls, and a man who had closed a valve to save his ship floated in the darkness, waiting for nothing. The fire began with a sound like tearing fabric, a sudden rupture in a fuel line, followed by a spray of atomized oil that ignited instantly when it touched hot metal. Flames spread across the engine room ceiling in a rolling orange wave, feeding on paint, insulation, and the oxygen that poured through ventilation ducts. Within seconds, the temperature inside the compartment climbed past 150 degrees. Within a minute, it was unbreathable. The engine room crew did not evacuate. They ran toward their stations, pulling on heat-resistant gloves, grabbing extinguishers, and moving with practiced efficiency toward the source of the blaze. The lead engineer shouted orders over the roar of flames and machinery. Shut down the ruptured fuel line, activate the foam suppression system, seal the ventilation ducts to starve the fire of oxygen. Every man knew his role. Every man moved without hesitation. But the fire was faster. It climbed the bulkheads, spreading along cable runs and pipe insulation. It reached the secondary fuel lines before the crew could isolate them, igniting a second blaze on the opposite side of the compartment. Smoke filled the space, thick and black, reducing visibility to arm's length. The heat became unbearable. Men wrapped wet cloth around their faces and continued working, moving by memory through the maze of machinery. The damage control officer arrived with a team carrying hoses and breathing apparatus. They linked the hoses to fire mains and directed streams of water toward the flames, but the water evaporated before it could reach the source. The fire was too hot, too well fed. It consumed everything combustible and reached for the main fuel tanks, massive reservoirs that held thousands of gallons of oil. If the fire breached those tanks, the explosion would split the ship in half. The decision came from the bridge: flood the engine room. It was the last option, the one no engineer wanted to hear. Flooding would extinguish the fire, but it would also destroy the engines, leaving the ship dead in the water. But there was no alternative. The fire could not be stopped any other way. The order was transmitted to the crew still inside. They had 2 minutes to evacuate before the seawater valves opened. Men scrambled toward the exits, dragging injured crewmates, abandoning tools and equipment. Some stayed behind to ensure critical systems were shut down properly, closing valves, disconnecting power, preventing secondary damage that could cripple the ship even after the fire was out. One engineer remained at the main control panel, watching gauges and monitoring fuel pressure. He needed to ensure the tanks were properly isolated before flooding began. If any fuel lines remained open, seawater mixing with oil could create a toxic sludge that would destroy the entire propulsion system. He worked methodically, flipping switches, turning valves, verifying readings on instruments barely visible through the smoke. The intercom crackled. 60 seconds until flooding. The engineer continued working, his movement steady despite the heat and the flames licking at the overhead pipes. He closed the last valve, checked the pressure gauge one final time, and confirmed the tanks were sealed. Only then did he turn toward the exit ladder. The smoke was impenetrable now. He could not see the ladder, could not see his own hands. He moved by touch, feeling along the bulkhead, searching for the rungs he knew were there. His fingers found metal. He grabbed the ladder and pulled himself up, climbing through heat that seared his lungs with every breath. Above him, the hatch began to close. Another crew member shouted down, urging him to move faster. The engineer climbed, one rung at a time, his strength fading. He reached the top and hands pulled him through, dragging him into the passageway as the hatch slammed shut behind him. Seconds later, the valves opened and seawater poured into the engine room with the force of a broken levee. The fire died instantly. Steam exploded upward, hissing against metal, filling the sealed compartment with superheated vapor. The temperature spiked briefly, then began to fall as water continued flooding in. Within minutes, the engine room was submerged, the flames extinguished, the danger contained. But the ship was crippled. With the engines flooded, there was no propulsion, no power for auxiliary systems. The vessel drifted, reliant on emergency generators for lighting and communication. Damage control teams worked frantically to pump out the engine room, but the process would take hours, perhaps longer. In the meantime, the ship was vulnerable, a stationary target in hostile waters. The crew adapted. They rerouted power from backup systems, prioritized essential functions, and prepared for the possibility of having to abandon ship if enemy forces appeared. In the flooded engine room, pumps labored to remove seawater while engineers assessed the damage. The main turbines were destroyed. Salt water had corroded seals, contaminated oil systems, and warped components. Repairing them would require a shipyard, weeks of work, and parts that were thousands of miles away. If this story has moved you, leave a like. It helps others discover how humanity can survive even inside the walls of captivity. But the ship was still afloat. The fire had been stopped. The crew was alive. And in the calculus of survival, that was enough. The vessel was taken under tow by another ship and escorted to port, moving slowly through waters where submarines hunted and aircraft circled. It took 4 days to reach safety, 4 days of constant vigilance and makeshift repairs, 4 days when every man aboard understood that survival was never guaranteed. It was earned, minute by minute, through discipline and the willingness to sacrifice everything for the fragile system that kept them alive. Water is patient. It does not burn or explode. It simply flows, seeking the lowest point, filling every void, adding weight with relentless inevitability. When a ship is breached below the waterline, the ocean pours through the opening with thousands of tons of pressure behind it. Each gallon adds 8 pounds. Each compartment that floods shifts the ship's balance. Too much weight on one side and the vessel lists. Too much weight overall and it sinks. Damage control teams did not fight water with force. They fought it with mathematics. They calculated how much flooding a ship could survive, which compartments could be lost without capsizing, and how to redistribute weight to maintain stability. They worked with diagrams that showed the vessel's center of gravity, its buoyancy reserves, its critical flooding points. They knew that saving a ship meant understanding numbers as much as understanding pumps and hatches. When a destroyer took a torpedo hit forward, the flooding was catastrophic. The torpedo exploded against the hull, tearing a hole wide enough to drive a car through. Water surged into 3 compartments simultaneously, filling them faster than any pump could remove it. The bow dipped sharply, listing 15 degrees to starboard within 2 minutes. Alarms screamed. Men ran toward damage control stations. The ship was sinking by the head, and everyone aboard knew it. The damage control officer studied the flooding diagram, marking which compartments were lost. 3 forward compartments were completely submerged, thousands of tons of water pulling the bow down. If the flooding spread aft, the ship would go under in minutes. But if the damaged section could be isolated, If the remaining buoyancy could be preserved, there was a chance. The order went out. Seal all forward bulkheads. Close every hatch, every door, every ventilation duct between the flooded section and the rest of the ship. Men scrambled through passageways, dogging down hatches, verifying seals, ensuring no water could leak through. The forward section was abandoned, written off, sacrificed to save the rest of the vessel. But isolating the damage was not enough. The ship was bow-heavy now, listing dangerously. If the angle increased, the deck would go underwater and progressive flooding would begin. Water pouring through ventilation openings, hatches, and any breach in the superstructure. Once progressive flooding started, it could not be stopped. The ship would roll over and sink within minutes. The solution was counter-flooding, deliberately flooding compartments on the opposite side of the ship to balance the weight. It seemed counterintuitive, adding more water to a sinking vessel. But physics did not care about intuition. The ship needed to be level. If that required flooding additional compartments, so be it. The damage control officer identified 2 aft compartments on the port side. They were empty, non-critical spaces used for storage. Flooding them would add weight to the rear and shift the ship's center of gravity away from the damaged bow. He gave the order. Valves were opened. Seawater poured into the designated compartments, filling them in controlled increments while crew members monitored the list angle. Slowly, painfully, the ship began to level out. The starboard list decreased from 15 degrees to 10, then to 7. The bow was still low, but the vessel was no longer in immediate danger of capsizing. Pumps were activated, working to remove water from non-critical flooded areas while maintaining the balance established by counter-flooding. The ship stabilized, floating awkwardly but afloat. The crew worked through the night. Engineers calculated weight distribution continuously, adjusting pump operations to maintain stability. Welders fabricated emergency patches, covering smaller leaks and reinforcing damaged bulkheads. Carpenters shored up weakened structures with timber braces, preventing collapses that could compromise adjacent compartments. Every man aboard understood that survival was temporary. The ship was wounded, fragile, one more hit away from going under. But the damage control system held. The mathematics proved accurate. The compartments sealed properly. The counter-flooding worked as designed. And when dawn arrived, the destroyer was still afloat, still functional, still capable of limited maneuvers. It withdrew from the combat zone under escort, moving slowly to minimize stress on damaged structures. It reached port 3 days later, listing 7 degrees and riding low in the water but alive. The lesson was studied carefully. Engineers reviewed the damage reports, analyzing what worked and what failed. They refined counter-flooding procedures, updated weight distribution tables, and improved sealing protocols. They calculated new limits, how many compartments could be lost in different configurations, how much list could be tolerated before capsizing became inevitable, how quickly counter-flooding had to be executed to prevent progressive flooding. The knowledge spread through the fleet. Damage control officers drilled their crews on weight distribution, teaching them to think in terms of tons and degrees rather than fear and panic. They practiced counter-flooding in port, deliberately flooding compartments and measuring the results, ensuring crews understood how to balance a ship when battle damage occurred. They built confidence in the system, proving that mathematics could overcome disasters that seemed insurmountable. Water remained patient. It still flowed through breaches, still filled compartments, still dragged ships toward the ocean floor. But crews learned to respect it, to understand it, to manage it with precision and discipline. They learned that survival was not about preventing damage. Damage was inevitable in war. Survival was about controlling damage, containing it, balancing it, and maintaining the fragile equilibrium that kept steel floating on water. Ships that followed the doctrine survived hits that would have sunk them outright a year earlier. Crews that understood the mathematics saved vessels that seemed beyond saving. And in the archives, tucked among engineering reports and casualty lists, were careful notations about ships that should have been lost but limped home instead, kept afloat by numbers and the men who trusted them. There was a sound that every sailor learned to recognize, the heavy metallic clang of a hatch being dogged shut, followed by the final thud of the locking mechanism engaging. It was a sound of finality, of isolation, of decisions that could not be undone. When that sound echoed through a damaged ship, it meant someone had just sealed a compartment. It meant someone might still be inside. It meant the line between survival and loss had just been drawn in steel. During battle, the sound came constantly. Hatches slammed shut as crews rushed to isolate damage, contain fires, and stop flooding. The rhythm was mechanical, relentless. Clang, thud, echoing through passageways and mixing with the roar of pumps, the hiss of steam, and the distant thunder of explosions. It was the soundtrack of survival, the audio signature of a ship fighting to stay alive. Men learned not to hesitate when the order came. If a hatch needed to be closed, it was closed immediately, without waiting to see if everyone had cleared the area. The doctrine was absolute. The ship came first. Individual lives were expendable when measured against the survival of the vessel and the hundreds of men aboard. It was a calculus no one wanted to accept, but everyone understood. War did not allow sentiment. The ocean did not offer second chances. A cruiser took a shell hit that penetrated deep into the hull, rupturing steam lines and igniting a fire in a machinery space. The compartment filled with superheated steam in seconds, a white fog so hot it could strip flesh from bone. Men inside had no time to escape. The damage control officer gave the order without hesitation: seal the compartment. The crew outside moved quickly, closing hatches on all access points, isolating the machinery space completely. Inside, the steam continued to build pressure. The temperature climbed past 300 degrees. Metal groaned under the stress, but the hatches held. The steam remained contained. The ship's propulsion system, located in adjacent compartments, continued operating. The sacrifice was immediate and total. The men trapped inside were gone before the hatches finished closing. But the ship survived. The sound haunted the crew. Days after the battle, sailors would hear it in their sleep, that metallic clang followed by silence. They would wake in the darkness of berthing compartments momentarily disoriented, unsure whether they were dreaming or if another hit had just occurred. Some men avoided walking past sealed compartments, unwilling to look at hatches that had been closed while shipmates were still inside. Others stood vigil, placing hands on the cold metal, offering silent acknowledgement to those who would never leave. The doctrine did not account for grief. It accounted for procedures, protocols, and the mechanical steps required to contain damage. It measured success in ships saved and missions completed. But the men who executed the doctrine carried the weight of every closed hatch, every sealed compartment, every moment when survival required abandoning someone who could not be saved. An officer who had ordered a hatch sealed during a fire wrote a letter home months later. He did not describe the battle. He did not mention the fire. He wrote only about the sound, how it echoed in his memory, how he heard it when he closed his eyes, how it followed him through every quiet moment. He wrote that he understood why the order was necessary, that he would give it again if required, but that understanding did not make the sound any easier to bear. Damage control drills included the hardest lessons. Crews practiced closing hatches under time pressure, learning to operate the mechanisms in darkness, in smoke, in chaos. But they also practiced the decision itself, identifying when a compartment was lost, when evacuation time had expired, when the hatch had to be closed regardless of who remained inside. Instructors forced them to confront the reality. In battle, you might be the one giving the order. You might be the one turning the wheel. You might be the one sealing the hatch while someone you know is still inside. Some men refused. During drills, they would hesitate, unable to close the hatch while imagining a crewmate trapped behind it. Officers corrected them immediately, explaining that hesitation in battle meant more deaths, not fewer. If a hatch stayed open, fire spread, flooding expanded, more compartments were lost, more men died. The only way to minimize casualties was to act decisively, without hesitation, trusting that the system, however brutal, saved more lives than it cost. But training could not prepare them for the reality. The first time a man closed a hatch knowing someone was still inside, something changed. The mechanism was the same. Turn the wheel, engage the dogs, verify the seal, but the weight was different. The sound was different. And afterward, in the quiet moments when the immediate crisis had passed, the memory remained, sharp, permanent, unforgiving. The ship continued operating. Battles were fought and won. The crew performed their duties with the same discipline and efficiency, but the sound of hatches closing became a marker, a dividing line between before and after. It was the sound of survival purchased at the highest cost. It was the sound of decisions that could not be unmade. It was the sound that followed them long after the war ended, echoing in silence, a reminder that some doors, once closed, could never be reopened. The pumps never stopped. Day and night they roared through flooded compartments, pulling seawater out by the thousands of gallons, fighting the ocean's relentless attempt to reclaim the ship. They were loud, mechanical heartbeats that kept damaged vessels alive, throbbing, chugging, vibrating through bulkheads and decks. When the pumps ran, the ship had a chance. When they failed, time ran out. Damage control teams monitored the pumps constantly, checking flow rates, watching for clogs, listening for changes in pitch that signaled mechanical problems. They cleared debris from intake screens, replaced worn seals, and rerouted power when primary systems failed. They worked in flooded compartments where water sloshed around their legs, in spaces filled with oil and fuel residue, in darkness broken only by emergency lanterns. They kept the pumps running because stopping meant sinking. But pumps alone could not save a ship. The water had to stop coming in. Every breach, every crack, every damaged seam had to be sealed or patched or somehow contained. Damage control parties carried materials for emergency repairs: wooden plugs, rubber gaskets, steel plates, quick-setting cement. They fashioned patches from whatever was available, improvising solutions when standard materials were insufficient. They learned to work underwater, holding their breath while fitting plugs into holes they could barely reach, surfacing for air and diving again until the leak was stopped. A destroyer took multiple hits during a surface engagement, opening several small breaches below the waterline. None were catastrophic individually, but together they allowed hundreds of gallons per minute to flood into the hull. The pumps could not keep up. Water levels rose steadily. The ship began to settle, riding lower with each passing minute. The damage control officer divided his teams, assigning each to a specific breach. They worked simultaneously, racing against the rising water. One team found a jagged hole the size of a dinner plate, torn through plating by shrapnel. They hammered a wooden plug into the opening, using mallets to drive it tight against the metal edges. Water sprayed around the plug, but the flow decreased dramatically. They wrapped the plug with canvas soaked in tar, creating a temporary seal that would hold until better repairs could be made. Another team found a split seam where two hull plates had buckled from the impact of a near-miss explosion. The gap was too wide for plugs, too irregular for standard patches. They fabricated a solution using a steel plate cut from damaged bulkhead material, bending it to match the curve of the hull and bolting it over the split seam. They packed the edges with rubber gaskets and sealed the joints with waterproof compound. It was crude, inelegant, but it worked. The leak stopped. The third breach was underwater, located below the accessible compartments. The team could not reach it directly, but they could hear it, a steady roar of water pouring through the hull. They tried pumping continuously, hoping to lower the water level enough to expose the breach, but the flow was too strong. They needed another solution. An engineer suggested mattress patching, an old technique that used the water pressure itself to create a seal. They took a canvas mattress, stuffed with kapok, and positioned it over the estimated location of the breach. The incoming water pressed the mattress against the hull, and the kapok expanded when wet, creating a soft seal that dramatically reduced the flow. It was not perfect. Water still leaked around the edges, but it cut the flooding rate by half. The pumps could now keep pace. Hour by hour, the water levels stabilized. The ship stopped settling. The crew continued working, reinforcing patches, improving seals, monitoring for new leaks. They worked with exhaustion pulling at their muscles, cold water numbing their hands, the knowledge that one missed breach could undo everything driving them forward. They did not stop until the ship was stable, until the pumps were winning, until survival seemed probable rather than desperate. But the work did not end. Patches were temporary. They held under calm conditions but might fail in rough seas or if the ship maneuvered aggressively. The crew had to monitor them constantly, checking for leaks, reinforcing weak spots, replacing materials that degraded. They scheduled shifts so someone was always inspecting the patched areas, always ready to respond if a seal began to fail. The persistence wore on them. Days of constant vigilance, interrupted sleep, and the grinding awareness that survival was never guaranteed. Men worked until they could barely stand, then worked more. They ate rations without tasting them, slept in shifts measured in minutes, and woke to alarms signaling new problems that needed immediate attention. The ship demanded everything, and they gave it. But the persistence worked. Ships that should have sunk limped into port under their own power. Vessels written off as total losses were repaired and returned to service. Crews that refused to surrender to flooding, fire, or fatigue kept their ships alive through sheer stubborn determination. They proved that survival was not about avoiding damage. It was about managing damage, outlasting it, refusing to accept defeat until the ocean itself admitted failure. In ports where damaged ships arrived, Repair crews marveled at the improvised patches, the creative solutions, the evidence of men working in impossible conditions to save their vessels. They saw wooden plugs driven into shrapnel holes, mattresses pressed against hull breaches, steel plates bolted over split seams. They saw the water lines marked on bulkheads showing how high the flooding had reached before being stopped. They saw the exhaustion in the crew's faces, the oil and grime coating their uniforms, the quiet pride of men who had refused to let their ship sink. The pumps continued running until the last drop of seawater was removed, until every compartment was dry, until the ship floated high and balanced again. Only then did they shut down, falling silent after days of continuous operation. And in that silence, the crew finally rested, knowing they had won.